Hello everyone. What we're going to do today is we're going to continue on with our graphing, and as you know, what we finished up with in the last section is we learned how to graph sine and cosine in this form, okay, in this form. So k plus a sine x sine bx, k plus a cosine bx. That's what we learned last section. Well, now we're going to add a little to this. We're going to start general and then we'll work up to the whole thing like this. But let's start out. I want to know how to graph this, or the cosine version. So we'll just look at the sine version because they're done the same way. But these are the two that we're trying to graph. Now notice the difference is the plus c in parentheses. So we know that how to graph y equals a sine of bx or cosine of bx. Okay, we know how to graph that, and what this c does here, what the c does is it causes a horizontal translation in the graph. We call that horizontal translation a phase shift. A phase shift. So it causes a phase shift in our graph. So we know what the graph of this looks like. A sine x. We know this has a period of 2 pi, and the beginning and the end of one cycle is generally 0 to 2 pi for that particular graph. Well, if that's the case, then it goes to state that bx plus c, that if this angle gives us a period of 2 pi, that bx plus c should give us a period of 0 to 2 pi. So what we can do is we can take bx plus c, set it equal to 0, and bx plus c, and set it equal to 2 pi. Now, what we're doing is we're taking what we already know in this, and we're applying our newfound bx plus c to it, because x equals this. X equals this. So bx plus c has to equal that as well. Okay? So now solve each one of these for x, and we get x equals negative c over b, if you solve this for x, to x equals negative c over b plus 2 pi over b. Okay, so why is that important? Well, look at what we have here. Okay, we have this negative c over b. This negative c over b. This is what we call the phase shift. Okay, the phase shift. Now you should already know what 2 pi over b equals. 2 pi over b will be your period of this new graph. Now don't get confused with what I said earlier. We're setting equal to 0 and 2 pi. The period of this new graph will not be 2 pi. The period gets adjusted based on our equations here. Okay, so we're adjusting the period. So that's not saying the period can't be 2 pi, but it will be adjusted from 2 pi. Okay, so the period can quite possibly be different. So when you're looking at your final answer here, and notice this right here, this is where one full cycle begins. This is where one full cycle ends. And that will always be the case solving it this way, where one full cycle begins, one full cycle ends. And this 2 pi over b will always, in the second part, will always tell you what your period is. Okay? What your period is. So let's actually put this to a problem so you can see it. Alright, so let's find the period and phase shift of y equals the sine of 2x plus pi over 2. Okay, so first things first, we're going to take 2x plus pi over 2. We're going to set it equal to 0, and we're going to set it equal to 2 pi. Alright, so this would give us 2x equals negative pi over 2. And if you divide by 2, you get x equals negative pi over 4. Okay, so that's where one full cycle is going to begin, at negative pi over 4. So what is this? What does negative pi over 4 represent? What does that represent? That is our phase shift. If you remember, I told you earlier, x is negative c over b. So our phase shift here is negative pi over 4. Negative c over b is the phase shift. So our phase shift is negative pi over 4. Negative pi over 4. Okay? That would be the phase shift. So, solve the second one. Excuse me, I'm sorry about that. Didn't mean to sneeze in y'all's ear. Alright, 2x is negative pi over 2 plus 2 pi. Now, I always write the period of 2 pi as the second one. It's just going to help you determine which one's the period and which one's the phase shift a little easier. Divide by 2. Now, it's dividing this by 2, and it's dividing this by 2. So, x equals negative pi over 4, again, plus pi. So, again, this right here, that's my phase shift, okay? The phase shift is going to occur in both parts. This right here is my period. So my period for this function is going to be pi. Now here's the thing. Students will leave it like this and I'll count it off. They'll leave it as negative pi over 4 plus pi and it'll get counted off. Now the only reason we're looking at it in this form right now is to help you determine the phase shift and the period, because that's what the question asked. Okay? But what is the interval of one full cycle? What is one full cycle of this graph? Well, we know it starts at negative pi over 4. Well, where does it end? Well, you need to finish this problem out. So this is negative pi over 4 plus 4 pi over 4 once you get a common denominator here. Once you get a common denominator. And so that's going to give you 3 pi over 4. So see, negative pi over 4 to 3 pi over 4 is, if you're thinking of that in terms of your graph, you can see how that gives us a period. This gives us a period of pi. Okay? Pi over 4 units to the left, 3 pi over 4 units to the right. Add those together, that gives you 4 pi over 4 units, which is pi. So that gives you a period of pi right there. So this is where one full cycle would begin. This is where one full cycle would end. Now, how would we find the points in the middle? Well, we would use our increment, which remember is the period divided by 4. The period divided by 4. And we'll get more into that with the next problem. But that's finding the period and the phase shift. And actually, I extended it and we found one full cycle. So that's one full cycle of our particular graph. Now, what if we wanted 2 cycles? Well, you would either add pi, so you would do 3 over 4 plus 3 pi over 4 plus pi, or you would do negative pi over 4 minus pi, and that would take you to the left and to the right, respectively. So you could find 2 full cycles either way, either going to the left, you could find another cycle on the left side, or you could find another cycle on the right side. But that would be how you would get it, is either adding or subtracting the period. Okay? Adding or subtracting the period. Alright, so let's graph one of these. Okay, so this is where it's going to get a little interesting for us, because let's go ahead and state what we know about graphing. Anything in this form, y equals a cosine of bx plus c, or sine of bx plus c, whichever one it is, the properties will be the same. We know the amplitude is the absolute value of a. We know the period is 2 pi over b. We already knew that. We've added the phase shift. The phase shift is negative c over b. And we know the increment is the period divided by 4. All these things, and of course we haven't added a vertical shift to this yet. We'll do a vertical shift problem here in a minute. But we could have a vertical shift with this as well, and this would be our complete entire problem worked out here. Alright, so let's look at a problem. Let's look at this one. Y equals 20 cosine of pi x minus pi over 2. And I want it graphed from -1 to 3. -1 to 3. Alright, so first things first. Let's find the amplitude. Well, that's easy. The amplitude is the absolute value of 20, which is 20. Okay? Amplitude is the absolute value of 20, which is 20. Alright, so, well, let's take, since this is in the form of bx plus c, we have to take, you can't just write periods 2 pi. You can't just write 2 pi over b. Okay, so you've got to remember what you're looking at. It's in bx plus c form. So we have to take this, set it equal to 0, and set it equal to 2 pi, because we're using cosine, of course. Sine or cosine, it will be 0 to 2 pi. Remember, there are some that are 0 to pi and things like that. Alright, so go ahead and solve this. And once you solve it for x, and you get x equals 1/2 here. 1/2. And for this one, you get x equals 1/2 plus 2. Now, don't combine them just yet, remember. We're going to add 1/2 and 2 here in just a moment to get our cycle. But don't add those two together just yet. You want to keep them separated like this. Why? Well, we know this is the phase shift, but this tells us our period. So I know my period is 2. My phase shift is 1/2. Period's 2. Phase shift is 1/2. Okay? Alright, so now we can add these two together. and you get 5 over 2. So I know one full cycle is from 1/2 to 5 over 2. 1/2 to 5 over 2. Now, pause the video right now and write all this information down, because I'm going to have to go to the next screen to draw it. I know it looks like there's a lot of screen down here at the bottom, and there is. It just gets harder to draw once well, we'll go ahead and try it. Anyway. Alright, so at this point, now, we don't have a vertical translation because we don't have any K up here, okay? But we do have a horizontal translation. We do have a horizontal translation. And so it's going to be, we're going to start where x is 1/2. So we're going from, notice we're going from -1 to 3. That's the length of the graph we're going to do. But 1/2 to 5 over 2 is going to be our 1/2 to 5 over 2 is going to be our one cycle here. So 1/2 is the first number in our t-chart. 5 over 2 is the last number in our t-chart. Now, how do we find what's in between? Okay, how do we find what's in between? Well, this is where our increment comes in. The increment is the period divided by 4. What did we say the period is? The period is 2. So our increment here is 2 divided by 4, which is 1/2. Now, this makes it easy because we're starting at 1/2. We're starting at 1/2. So if my increment's 1/2, then I'm going to go up. I'm going to add 1/2 and get 1. Add another half and get 3 over 2. Add another and get 3 over 2. I'm going to add another half and get 4 over 2, which is 2. And then I'm going to add another half and get 5 over 2. So you see how I'm doing that. I'm just adding 1/2 to each of the numbers in the x value to increase my increment. That means there should be, if you look here, increment means there should be 1/2 between these two numbers. Between every number, you should have 1/2. Okay? Because that's our increment. So that's how we're getting our x values. Okay? That's how we're going to get our x values. So, now that that's done, take your x's, plug it back in the original equation right here. Get your y's. Okay, so if I take 1/2 and plug it in, that's going to be pi over 2 minus pi over 2, which is 0. And we know the cosine of 0 is what? Hopefully you've learned your unit circle by now. The cosine of 0 is 1. And 1 times 20 is 20. So when you plug that back in, that gives us 20. Alright, well, we have 1, put 1 in there, so that's pi minus pi over 2. Now you're going to have to get common denominators with a lot of these fractions. This just happened to work out nice on the adding 1/2 each time on the increments. There are going to be times when you have to get common denominators with the increments as well. So be prepared to get common denominators with fractions. So if we do pi minus pi over 2. So that's going to be the same thing. That's going to be the same thing as 2 pi over 2 minus pi over 2 when you get a common denominator. Alright, so I'm just plugging 1 in for x in our function. I got pi minus 1/2, and that's the same thing as 2 pi over 2 minus pi over 2 when you get a common denominator, which is just going to give you pi over 2. So what's the cosine of pi over 2? Well, that's going to be 0. So 0 times 20 gives me 0. Take 3 over 2, plug it back in. Guess what that's going to give you? If you know what a cosine graph looks like, that's going to give you negative 20. What is 2 going to give you? If you know what a cosine graph looks like, you know that's going to give you 0. What's 5 over 2 going to give you? Again, I know I keep saying this, but if you know what a cosine graph looks like, you know that's going to give you 20. Now, if you don't know what a cosine graph looks like, plug them all in for x, figure them out. But after you get the first couple, if you know what the graph looks like, you should be able to go straight down the page making the t-chart. Alright, so I'm going to go ahead and this is going to be 20 and negative 20 because I'm running out of room on this page. So let's keep the scale the best we can. It skews an improper scale there. Alright, so we have 1/2 20, so that's going to be up here. We have 1 0, it's on the x-axis, 3 halves, which is 1 1/2, and negative 20, so that's going to be down here. 2 zeros back up on the x-axis. 5 over 2 is 2 1/2, 20. Now, notice a second before you start drawing your lines. Notice if you just draw your line there, you have gone one full cycle. Notice we have gone one full cycle. We've gone one full cycle from 1/2 to 5 halves. That's one full cycle. We found that out right there. Okay? But notice what our question asked us to do. Our question asked us to graph it from -1 to 3. So we've got a little bit more work to do. So let's look at 3 right here. What's it going to be at 3? Well, look at our pattern. Okay? We went 20, 0, negative 20, back up to the line at 2 was 0, positive 20, we're going to go back down to the line at 0. So 3 is going to be back down at the x-axis. Okay, now if you have no clue, if that confused you the way I did that by reading my graph, I'm just looking at the trend of the graph to get these other points from -1 to 3. But if that confuses you, you can always use the increment and measure it out. You can go from -1 to 3 using a t-chart, just like we did before. Go from -1 to 3 using a t-chart. Just make sure your increment is 1/2 for your whole t-chart, and you can punch that out very easily in the t-chart. It's just going to take you a little bit longer time to do it, but you could punch that out very easily in a t-chart and have it done. Alright, so now we're going backwards. We're at 20, but notice the pattern. We go back down to 0 on the x-axis. Then we go, since we're at positive 20 here, we're going to be at negative 20 right here, and back up to the x-axis at -1. So that would finish out our graph like so. So our graph looks exactly like that. Okay, so now again, if you don't like trying to look at the original, we looked at the original cycle, the full cycle that we found. We looked at that. I looked at that and got my other points. If you don't like that, like I said, use a t-chart. Start at -1, go up 1/2 because that's the increment. Go up 1/2 every time, so it would be -1, -1/2, 0, 1/2, 1, 3 halves, 2, 5 over 2, 3. That would be your x values. Plug them all in the function and get the y values just like we did in the beginning. There's no shame in doing that if that's what you need to do to get it right. But get in the habit of being able to look at the graph and get those other points because it'll just make your life a little easier. All right, so that is graphing something in the form a cosine bx plus c. So that'll be the end of this first part of part 3.3. We have one more problem I want us to work, and then we'll actually be done with section 3.3. Have a great day.